This video will cover a solution guide to problem 42 from chapter 10. A diver comes off a board with arms straight up and legs straight down, giving her a moment of inertia about her rotation axis of 18 kg-meters squared. She then tucks into a small ball, decreasing the moment of inertia to 3.6 kg-meters squared. While tucked, she makes 2 complete revolutions in 1 second. If she hadn't tucked at all, how many revolutions would she have made in the 1.5 seconds from the board to the water? Because the diver is not under the influence of any outside torques, we can apply conservation of angular momentum to calculate how many times she would have rotated had she not tucked a half a second into her dive. From conservation of angular momentum, we know that the diver's initial moment of inertia multiplied by what would have been her angular velocity is equal to her moment of inertia when tucked multiplied by her angular velocity. We were not given her angular velocities for either the tucked or untucked version of her dive, but what we do have is the time she would have been able to rotate for each version of the dive and the amount of revolutions she would have made while in the tucked position. So what we can do is re-express the angular velocity in terms of the angular displacement and time. Doing so gives us an equation where the only unknown variable is the one we're looking for, her angular displacement if she had not tucked into a ball during her dive. Rearranging the equation for this value and substituting in the information we were given in the problem, we find that had the diver not tucked into a ball, she would have only made 0.6 revolutions before hitting the surface of the pool.